Welcome everyone. Welcome to this video. So today I will illustrate how you can use inbuilt gear components and then try to do motion studies on the same gears. So let's go straight into the video. So first thing, we'll open SolidWorks in assembly mode. So you go to new. Okay, so new, when you click on new, then you choose assembly. Okay, so we are in assembly mode, like you can see. So you close this one and you close also this one. Okay, so change our appearance to plain white. So next, first of all, we'll draw some circles. So we choose our plane, let's say flat plane. Okay, so sketch. So we'll draw 2 circles. For this purpose, we need to keep our units into inches. So you can just change from here. If you want millimeters, you can change. Okay, so you convert them to inches. So now we pick a plane, sketch. So we'll draw 2 circles. So 1 circle with a diameter of 6 inch. So we'll keep the diameter 6. Then we'll pick another circle with a diameter 3 inch. So smart dimensions. So this is 3 inch. 3 inch. Okay, great. So next, we have to make these circles tangential. They have to be tangent. The surfaces of these, or the arcs of these 2 circles have to be tangent. So you select this, hold control, then you also select this, then you choose the relationship tangent. Okay, next, so you choose the center of this circle and this circle and then make them horizontal. So you click on this center, hold shift, then you also choose the center, then you can choose from here or here. So you choose horizontal. So you can see that our sketch is fully defined. So now what do we do? Let's go to tools. So you have this icon here, design library. So when you click on design library, you see this. So if the tools doesn't appear, so let's say you open the tools, it has to show like this. So for some cases, for some it won't appear, so you have to go to this option here, then you go to add in, then you choose this SolidWorks toolbox library. So you choose this one, you tick this one and tick here, then you choose OK. That's how you enable that tool. Okay, so when you come here, so we go to inch. These are standards which we want to work on. Then you come to, there are a lot of things. You have bearing, bolts. So for this purpose, we want a power transmitting gear. So we go to gears, then we'll work with a spur gear for today. So we have this spur gear, you drag and drop it here. Okay, so now we get to edit. So there is this diametral pitch. You can set whichever you want to pick. So for this video, just keep it 6. Then you choose the number of teeth. So the number of teeth will pick 36, but you can pick whichever number. But for this one, we want 36, and then half of 36, 16. That's how you pick. So if you pick, let's say 144, or let's say you pick 20, then the smaller gear needs to have half the number of teeth. Okay, Yeah, but there are some design constraints which we also have to pay attention. So we have pressure angle, you can pick any. Then face width, you can change. Let's say you want a smaller one or a bigger one, you can keep if you want one. So you see that the width it will change automatically. So hub, if you want, you can also include a hub. Let's say two-sided hub, you can include a hub. Okay, you have a hub inside. Then hub diameter, you can also say, let's say 1. Okay, so you have that hub diameter. Overall length 2. Then you have normal shaft diameter 2 by 1. So just leave it like this. Then you have also a key to lock this gear on its shaft. So you can pick, okay, the number of teeth. Just like that. So we're done. You can just click OK. So it will enable another gear. So another gear, you can press it anywhere. So let's say here. It will also enable duplicating. So if you want 3, you can click. If you want 4, you can just continue clicking. But we will just want 2. Okay, next. So we want to edit this small gear. So you right click, choose a face, then right click, edit toolbox component. So you come here on edit toolbox component. So we'll leave the diameter pitch same. Then the number of teeth we keep half. So it was 36. Half of 36 is what? 18. So we keep the number of teeth 18. Then pressure angle will leave the same. Hub on both sides. Okay, these. Then the shaft. So we'll keep half. So choose 1 by 8. So half of that, this is 1 by 8. Okay, that's just the central shaft. Okay, looking good so far. You can just choose okay. So we have our 2 gears. Okay, first job done. Okay, so if you see, if you choose this plane, front plane, normal, see that our gears are on the opposite. They are pointing on the other side, but we want their faces to face the front. Okay, so how do we rotate the gears? So you go to assembly mode, you come here, move component. So you say rotate. So you can choose the face. You choose the face. So you can see that this one is not rotating. Okay. So the first one won't rotate because we have not enabled floating. So you choose one face, then right click, then you choose float so that it can rotate. Okay, then you choose rotate. Now you can see that, okay, it can move. Okay, so great. So it's able to move. Okay, so you can see that, okay, our gears can move nicely. So what next? So what do we do next? So now let's say we go to move component. So now we're not clicking rotate, you go to move component. Okay, so move component, we choose the face and the plane. So we want to move it to the front plane. Sorry, let's see. No. Okay, sorry. Let me just go back. We're not supposed to move. Okay. So we have to meet because we want these faces to align with this front surface. So we are not going to move, rather meet. So for this we use meet. So when you choose this meet, so you click the face, then we want this face to be aligned with the front plane. So we choose the front plane. So you can see that this face is now aligned. Okay, then you apply. Next, you also choose meet. Then you choose this face, and then you choose the front plane. Okay, you can see that, okay, these two are aligned. Okay, nice. Okay, so click OK. Next, so you can see that these circles are aligned with they are aligned, they are on the same plane as the gears are on the same plane as these circles we drew at the beginning. So now we have to align, we make concentric relation, this circle and this one, this gear, then this circle with this gear. Okay, so what do? We choose meet. So you can choose this outer edge, okay, and this circle, and make the relation concentric. Okay, next you choose this edge and this circle, make the relation concentric. Okay, so our circles or our gears are now aligned. So these circles were just to help us or guide us on how to align the gears. So you can see that they are properly aligned. So you can check that they are properly aligned. You can see that they are properly aligned. So now we will hide these sketches. Okay, so we'll hide the sketches so that we have the clear visualization of our gears. So we can add some color to these gears. Okay, so let's add color, or add material rather, anything. So let's say pick red, we choose this guy to be red. Okay, apply, then you also choose color. Let's say brown, choose this guy. Okay, so at least we have two distinct gears. We can visibly see the differences. So now you can inspect to say, the parts, do these parts, are they meeting or are they able to move? So you can come here on move component. So when you click move component, you choose physical dynamics. So you're trying to inspect. So before you start to move, you need to make sure that these the teeth are okay. So it's already colliding. So let me first close it. It's telling you that this in collision, it can't move. Okay, so first of all, so let me first move it. Okay, free drag. So you see that it's not in contact. You have to ensure that it's not in contact. Okay, it's not in contact. You can see that they are independent. That's why now you can choose, okay, physical dynamics. Then now you can try to move one. So you can see, okay, is it able to move? So there are times where the number of teeth are not properly aligned. It won't be able to move the other one, to be jamming. So for designing, you'll be able to tell that, okay, I need to decide proper number of teeth. Okay, so we are okay. Our gear can move freely. So we need to make sure that they are not in contact, because the next step also requires the gears not to be in physical contact. So we just have to, okay, like this is free. Okay, so next we now go to motion study. So you just click on new motion study. So when you click on new motion study, we want to see how these gears will rotate. Okay, so you first of all, you start with motion study properties. So here, you click here, number of frames per second. So you can keep maybe 50, or let's say 60. 60, that is our number of frames per second. Then you have gravity. If you want, you can enable gravity, but it's not important here. So contact. So you choose bodies which are in contact. So the bodies in contact is this and this. Okay, so you've chosen these two. You click OK. Next. So this is contact. Then there is also spring. There is also motor. So one has to be rotating. One gear has to be rotating. So for that, you choose this bigger gear to be the primary mover as our motor. So you choose the edge. So let's say it's this. It was also showing you the direction. You can change the direction if you want, or just keep it like this. Then revolutions per second, also the speed, let it be moving at 10 for this example. So you choose 10. Next, you have, this is not important for this. Okay, animation wizard, we can also choose some animations. Let's say we want it to be rotating, we want it to rotate along the x-axis, the y-axis, 4 rotations. So you can keep Z whichever you want. Next, starting time 0, duration 10. Okay, finish. Okay, so we have that. The next, so here on animation, we keep basic motion. So there are also other options which you can pick here, like time, you can drag. Okay, yeah, so it will move up to 10 seconds. So let's now keep it like this. You can also save the animation. So let's play now and see what is happening. Okay, so you can see our gears are rotating along the y-axis, and we chose the rotation to 4. So you can play and see. You can see that our gears are rotating nicely. Okay, so this wizard, we can also let's say next, let's choose 1 rotation. Okay, you can also pick anti-clockwise for how many seconds? Let's say just 5 seconds. Then you can click. So to show you how, this is how you create animations and show how the gears are rotating and stuff. Okay, so it can clearly show you how this gear will perform. So this is how you design inbuilt gears. So you can do the same for other types of gears like Helix. So the only disadvantage with a Spur gear is at higher speed, you find that the teeth, they won't be meeting correctly. So these are usually used for low speed systems. Yeah, because the meeting of the teeth, it will be very noisy one. There will be higher noise, and also not only noise, like that problem of teeth meeting. They don't properly meet at higher speed. Okay, so thank you for watching.